Hello everyone. So today we are going to talk about casting and operators in Python. So the overview of this video. So we'll see first what casting is. We'll see about the different operators in Python, and then out of those we will look into a little bit more detail for the following operators, which are arithmetic operator, assignment operator, comparison, and logical operators. So let us begin. So what is casting? Now casting or typecasting is converting a variable of one data type into a different data type using the inbuilt method. Now why is this done? This is done for various reasons. It can be as simple as extracting numbers from a string so that you want to perform certain calculations, or storing a number as a string because it is required in the certain field if you're maybe storing it in a database or something. So there are various reasons why casting is done. Now let us see how it is done. It is very easily done in Python. For example, let's say if you have a string, like let's say if you're storing a number inside double quotes in this, or if you see z equals to int and then you have 3 in double quotes. So inside this brackets you will see that there is a string, but even though it contains a numeric value, it is still a string because of the double quotes. Now if you want to convert it to a number so that you can perform mathematical calculations, all you have to do is you have to write int and then put it inside the bracket, so that will convert it to integer. Now similarly for floating value, let's say if you have a value like 2.8, so if you just want to extract the integer value, that is 2 in this case, you will just simply write int and in brackets you will put your value which you want to typecast to integer. So if it is already int, the output will be the same and there won't be any difference. Like over here, if you write int in brackets, you write 1, your output will be 1 itself. So similarly, like we can convert to int, we can also convert to float and to string by writing float or by writing str. So for converting to float, you simply write float, and then even if it is an integer like 1, 2, 3, the float value will return it with a decimal point. So if it is 1, it will return 1.0. If it is 2, 2.0 will be returned, and so on. Then 2.8 is already a float value, so it will return as it is. And if you have a string, so from a string, inside the string, if it is a decimal value, it will return as it is, but if it is an integer value, it will return it with decimal. So that is about conversion to float. Now conversion to string is pretty simple, just like the others. You just write str, and no matter what you write inside, it will be converted to string. So we'll see this in the form of code. So I'll be continuing in the same code file that I've been using for this video series, and I'll just write a comment. Let's say casting. So we can begin. Let's say for example, if I have a variable v1 and I'm storing a double quotes string and I'm storing a into it. So now if I try to cast it into an integer, so I'll get an error because it is a string. So let's say if I want to cast it to a string, it will give me error because this is an alphabet and you cannot convert it to integer like this. So that is why I'm getting an error. But if I write 3 over here, then I can convert it to integer and I'm getting the output as 3. So initially if I print the type of the variable, I'll get it as string. That's because I've defined it in double quotes. So it's saying class string, but then we are converting it to int using the casting for integer. So that is how you convert a string to int. Now in this, let's say if I have something like 3.0, let's see what happens. So that will give me an error because we have a decimal point here. So when you are converting it, first you will have to convert it to float and then you'll have to convert it to int. So let's say another variable v2 equals to float of v1, and then I'll print int of v2. So this way I'll get it correct. So once again I'll remind you that if you have a decimal point inside the string, you cannot directly convert it to integer. First you have to convert it to float, and on converting it to float then you can convert it to int. So I can write it in one sentence itself. So if I just write here and add additional bracket, I'll just write v1 and I'll remove this line. So this will also work. Sorry, I have to write float inside. So this works. So first you are taking the string which is v1, which contains 3.0. You're converting it to float, which will be a numeric 3.0, and then you're converting it to int, which is simply 3. Then you can even take 3.5 or any decimal number and it will work for you. Similarly, if you directly have something like, let's say v2, so I'll just take it in a new cell. Let's say v2 equals to 72.99, and I want to print by converting it to int. So it will give me 72. So you have to note that it will not round the number off, even though it is 72.99. We are not rounding it off. We are directly taking the integral value or the integer value. So that is how you use casting or cast different data types to int. Now similarly you can go ahead with float. So let's say if I have a variable, let's say n1 equals to 72, and I will print, first I'll just print n1, so I'll show it to you that it is printing it as 72 as it is, but once I convert it to float, it will print 72.0, that is with a decimal place. So it prints 72.0 as it should. And if I take a string, so that will again give me 72.0. So like you saw, when it is a decimal point is there in the string, and if you want to convert it to int, you have to first convert it to float. But same is not the condition when you have integer in string and you want to convert it to float. It will directly add the 0.0, and even if you have the decimal, it will give it correct. So that is how you convert it to float. Now if you want to convert anything to string, let's say a equals to 56, and I'll write print str a. So it will print 56 as it is, but the type will be string. So if I write type over here, so the type will be string, but if I print the type of the original variable, that will be integer. So like you can see, the class is initially int because a is 56. Then we are doing typecasting over here and finding out the type, it is string. So even though it will not change in appearance on the output, but the class is changing. And if you want to perform calculations, you'll have a problem. Like let's say if I have b equals to 1. So now if I'm converting c equals to string a, and then I want to print something like a plus b, sorry, a b plus c. So I'll get an error because this is a string. C is containing a string and b is a number, so you cannot add number and string. See, you cannot add integer and string, so that's why I'll get an error. But if I change both of these to string, if I make b as 1, so your output will be 156. This is because you are directly concatenating string. We have seen about concatenation before in the strings video, and when you have two strings, if you write plus in between, it will simply concatenate them, that it will simply join them. So when the first string is 1, that is b, and the second string is 56, so it is just joining 1 and 56, which makes it 156. Now similarly, if you want to perform calculations for string, let's say if you have, let's say a1 equals to 56, or let's say 50, and a2 equals to 27. Now if I want to add these both numerically, I will have to first convert them, because if I don't, then it will just be concatenating the strings like we saw earlier. So right now this should give me 5027, as it does, and if I want to actually add them, I'll have to convert them to integers. So I can convert them directly inside the print statement, or even while declaring the variable I can convert them. So now that I'm converting them to int, it is giving the output 77, which is the numerical addition over here. And like I said, I can even convert them over here. So I can convert them while defining itself, and it will still give me 77. Now similarly, you can also add two decimal points, I mean two float numbers, or one float and one int. So you need not do typecasting there, like for example 72.6 plus 5. So your answer will be float, which is 77.6. But if you have two integers, your answer will also be an integer, like 2 plus 5 will give you 7. So you need not typecast it when both are numeric data types, but you have to typecast if it is string and if you want to perform calculation. So that was about typecasting. Now we'll go ahead with the presentation. So we just saw these examples and saw how typecasting is done in the code form. Now the next thing on the agenda, so the types of operators in Python. So there are quite some types, like arithmetic operators. We have relational operator, assignment operator, logical operator, bitwise, membership, and identity. But the four of these are most commonly used, and that is what we will see in a bit more detail than the others. Like we have arithmetic operator, relational, assignment, and logical. So these four are used more often, and relational operators are also known as comparison operators. So the both are the same. So let us begin. So arithmetic operator, so it is simple, used for mathematical calculation. It is simply used for that. We have plus, which is addition, minus, which is subtraction, you have asterisk, which is multiplication, slash, which is division, then the percent symbol, which is actually modulus, the double asterisk is exponent symbol, and the double slash is integer division or floor division. Now addition we all know, like 4 plus 2 is 6. Subtraction we know 4 minus 2 is 2. Similarly multiplication and division we know. Now modulus, most of you might know, but modulus is simply going to give you a remainder after dividing. Let's say 5 mod 2 will give you 1, because when you divide 5 by 2 the remainder is 1. So modulus is nothing but it gives you the remainder. And exponent, so again this is also pretty simple. You just write double asterisk or double star, and this will be calculated as 5 square. So if you write 3 over here, it will be calculated as 5 cube. So this is the base and this side is the power. So 5 raised to the power of 2, which will give you 25. Now integer division. So integer division will give you only the integral value after dividing. So 5 floor division 2 will give you 2, because the quotient is 2 and remainder is 1. So just like modulus gives you remainder, this gives you quotient. Similarly, minus 5 divided by 2, your quotient will be minus 3 and your remainder will be 1. So that's why you will get minus 3 as the remainder. So let us see this by code. So let us see the arithmetic operators. So addition, subtraction, multiplication, and division are pretty common, and you can even try them out yourself. So just like addition, 5 plus 7 will give you 12. Similarly, 5 minus 7 gives you minus 2. Then 5 divided by 7, so that will give you a decimal value. and 5 multiplied by 7 will give you 35. So those were the 4 basic ones. Now just like when I got a decimal value with 5 divided by 7, if I wanted it to be integer, I'll just simply write double slash, which gives us our floor division, so which is 0 because it is 0 point something. Now if I just write 7 divided by 5, it will give me 1, not divided, actually floor division. So that was about the double slash or the floor division I mean. And for modulus, if I have 5 modulus 2, I'll have to print it, of course. So that will give me 1 because when you divide 5 by 2, the remainder is 1. Similarly, if you divide 7 by 4, your remainder will be 3. And 7 divided by 7, of course, remainder will be 0. So that is the modulus. And for exponent, so 2 raised to 2, so that gives you 4. So I'll take another number like 5. So 5 raised to 2 gives you 25. Similarly, 5 raised to 3 will give you 125. So there you go. So if you just write 4 over here, that should give you 625. So that is the exponential. And I think we've covered all the arithmetic operators. We can go back to our presentation. So the assignment operators now. We saw with the arithmetic operators and assignment operators. So the basic or the most simplest assignment operator is equal to. We've used it already many times. You use it to assign value to a variable, like for example y equals to a plus b or y equals to 10 plus 20, and whatever the calculation answer is or the result is, it will be stored in the left hand side variable, which is y in this case. Now just like we have equal to, we have various other assignment operators which are added after the arithmetic operators. So if you see below and if you ignore the equal to sign, all of these are arithmetic operators which we just saw. We have addition, subtraction, multiplication, division, modulus, exponent, and floor division. So when you add equal to in front of it, it is assignment operator because after doing that sort of calculation, the value is then assigned to the variable which is present on the left side. For example, if you write m plus equals to 10, you can simplify it and write it as m equals to m plus 10. So it is for your better understanding. These both work the same. So similarly, m minus equals to 10 means m equals to m minus 10. So if you want to update the value of the variable on left side and you want to update it with some different constant or by any other variable, you can directly use these kind of assignment operators. They're also known as shorthand operators. Similarly with multiplication, division, mod, exponent, and floor division, like if you write m star star or m asterisk, you make the asterisk twice, equals to 2, that also means m equals to m raised to 2 or m equals to m square. Similarly with floor division, m double slash equals to 10, it means m equals to m floor division 10. So this is also again pretty simple once you understand it, and we'll see it using the code. So let's say a equals to, okay, we'll directly start with, yeah, a equals to, let's say 10, and if I write a plus equals to 5 and then I print a, so this should give me 15 because a initially has the value 10 and then you are adding 5 to it. So you're, like I said, this is equal to writing, I'll just write it as a comment, a equals to a plus 5. So this is the same as a equals to a plus 5. Now if you do not define the value of a already, you will get an error. So right now you're not getting an error because the value is already stored in the runtime. I'll just take a new variable, something like z2, and then I'll print z2. So this time you should get an error because you do not have an initial value of the variable z2. So you have to make sure there is already an existing value which is being stored in that variable. only then you can use the shorthand operators, which are the assignment operators. So let's say z2 equals to 10, back to how we started, and then you'll get 15. Now similarly, if I write minus z2 minus equals to 5, so 10 minus 5 gives me 5. Similarly, if I write asterisk, that is multiplication, answer should be 50. So this is the updated value of z2. So whatever calculation you're doing over here, it is directly being updated inside the variable itself. So it's updating and storing again back into the variable. So this is why it is used. Similarly with divide, 10 divided by 5 will give you 2. So it is 2.0. So division in Python will give you a floating value. Then floor division will give you integer value, which is 2 in this case. The decimal will be removed. And we have the last one, exponent. So this should give you 10 raised to 5. So you'll see 5 zeros over here. So yeah, so this is how assignment operators work. We'll go back to our presentation to see comparison or logical operators. So we have comparison operators first, and last we'll be seeing logical operators. So comparison operator are also known as the relational operator. Now they're very simple. We have been seeing these since school. So something like less than, greater than, less than, equal to, greater than, equal to, double equal to, which might be new for you if you are new to programming, and exclamation equal to, which is read as not equal to. So these two might be considerably new if you haven't had any experience in programming before, but it is pretty much used in each and every programming language. So less than, I need not tell you. So all these operators will give you a boolean result, either true or false. So for example, if you write 5 is less than 2, you'll get false because 5 is not less than 2. And in fact 2 is less than 5. So if you write 5 is greater than 2, you will get true, which is correct. So 5 is less than equal to 2, again false. But if you write 2 is less than equal to 2, you'll get true. So these are pretty basic ones. So what double equal to does is it compares equality if both of them are equal, the left hand side and the right hand side. Now usually you write single equal to for that in maybe notebook or whenever you're writing somewhere, but a single equal to in programming means assignment, more particularly here in Python. So it is used for assigning a value to the left hand side. That's why if you want to compare if two values are equal, you have to use double equal to. And just opposite to double equal to, we have not equal to, which is represented by an exclamation mark along with an equal to sign. So 5 is not equal to 2. So this is a correct statement. That is why you are getting true over here. Now similarly 5 is equal to 2, which is wrong. That's why you're getting false. So we'll just see this in the form of code. So I'll take two variables, just a5 maybe, a5 equals to 10 and a6 equals to 7. So if I write print a5 is greater than a6, which is 10 is greater than 7, it is true. Now if I write if a5 is greater than 10, a5 itself is 10, that's why it will give me false. But if I write greater than equal to, that will be true because a5 is equal to 10. So these are pretty basic ones, and you can try comparing it with string. So that will give you an error, of course, because you cannot compare string with integer. You first have to convert it using casting. But if you want to use double equal to, you most definitely can compare them. So 11 is not equal to 10, of course, but if I write 11 and both sides 11, but it is not equal to here, it is giving false. These two are not equal. This is because the 11 here is of data type string, whereas the 11 here is of data type integer. So if I convert this one, then it will give me true. Then both of them will be same. But without typecasting, it will not be the same. So you can also use it to compare strings. So if I just take another string like ABC, so of course these two strings are not equal, it will give me false. But if I write 11 in string, again these two are true. So you can compare strings as well as integers. If I write 11 and 11, so now both are same, that's why you'll get true. And just the opposite of it is not equal. So double equal to and not equal to can be used with string, whereas the other comparison operator cannot be used with string, especially the greater than, smaller than, and all. So that is about the comparison operators. Now we'll go back to the presentation. So logical operators, now this is the last one which we are going to discuss, and the other operators like identity, membership, and bitwise, they are not included in the basic ones, and you can discover them on your own. So there are only three logical operators, which is and, or, and not. So it means logical and, logical or, and logical not. So and basically, so again this will return a boolean type of output. So that is if okay, for and, if both the sides are true, only then it will return true. In all the other cases it will return false. Or will return true if any one is true, either this or this. So that will give out the final output as true. But if both the sides are false, then or will also give you false. So logical not will just give you the opposite of what is actually there. Like if you have not true, it will return false, basically like a negation. So we'll see this in the form of code. So let's say print true and true. So that should print true. Now you might be wondering why it's not printing it as it is, true and true. That will be done only if you put double quotes. Then it is not a logical expression, it is just a string. So if I remove the double quotes, it is a logical expression. So if this side is false, then it will return false, because both the sides should be true for and the and keyword to return true. Now if this might be confusing for you, I'll just take two variables, let's say b1 and b2. So inside b1 I'll store something like 7 is greater than 2, which is true, we all know that. And in b2 I'll write something like uh, 2 is equal to 2 double equal to 2. Okay, I'll just make it 4. So the first one is true, I'll just write it in comment so it is easier, and the second one is false because these two are not equal. Now if I write b1 and b2, so true and false. So like I said earlier, this will only return true when both the sides are true. That is, b1 should be true and b2 should be true, but that is not the case, that's why we're getting false. Then if we write or, we'll get true. So if any one value is true, the final output of or will be true. But if both the values are false, then the final output will be false. Like if I make it over here, this should be false, then this output will be false as well. So that is about and or the logical and logical or. Now what is not, let's say print not true. So it will directly print false. If I write print not false, it will give me true. So just the opposite of what is inside the bracket of this not keyword, it will give you that as the output. So since we have false, the opposite of false is true, your output will be true. So all these three logical operators provide you with Boolean output, and they're all pretty easy. So apart from this, bitwise operator, it, you know, on every bit you can do operations like or, on, and so on. So there are a few more operators, like I said, identity, membership, and bitwise. So you can go ahead and explore them by yourself. So that is it from this video, and I'll see you in the next one. Thank you.